All right, next, 13 and 14 deal with domain and range, which is referring to the graph of these functions. So I'm going to show you quickly on the calculator, just as a reminder, that these exponential functions have a j-curve to them. So what I've done in blue we'll see the one that we actually care about, the 1/4 to the power of x. But next to it in red, I also want to show you what 4 to the power of x would look like. Okay, so this one is decay. We know that it's decay because our value is less than 1, whereas the base here is greater than 1. So the blue one will be decay, the red one will be growth. So all I've done is I've put this in y equals, and I'm just going to click graph. Okay, so our decay one is in blue. See how it slopes down to the right? Our red one would slope up to the right. So this one, because it's decay, it's going to go down to the right. Now if I put in the +7 and the -2, remember that's going to shift me right 2 and up 7. So I can show you what that looks like. I'll go back here. All right, so I'm going to say x -2. And then we have +7. And I'll go back to my graph. So what it does is it shifts it up 7 units. So this right here, this is 7. That's going to be our asymptote equation. It also shifted us right 2. Ignore the red one. Remember, that's 4 to the power of x. So I'm going to draw in my axes here. Okay, so right here, that's +7. And over here, that's 2. So right 2, up 7. So when I'm referring to domain and range, I'm talking about left to right. Well, it's going to go left forever, and it's going to go right forever because of those 2 arrows. But it's not going to go down forever. When we talked about an asymptote equation, I kind of referred to it as like a barbed wire fence or an electrical fence that you don't want to touch. So it'll get close to it without touching it. So we're going to start at 7, soft parentheses, because it's not actually going to touch it. And then for the up part, it'll go to +infinity. So this one is still decay, so it still technically would slope down to the right, but the difference is now there's a negative. So what it actually does is it flips over this way. So it's a bad example. Just trying to get it to reflect. See if I can do it this way. Format. There we go. Okay, let's get it to... It's not going to let me do it. But anyway, our reflection over our x-axis is just going to look like this if I were to fold my paper in half. Okay, so the negative causes it to flip like that. So now our domain is still left to right forever, but instead of going up forever, it's going to go down forever, and it'll stop at whatever your vertical shift is. So in this case, it's going to stop at -2. And again, it's a soft parenthesis because we don't want it to actually touch that plate.